So in this video, we are going to cover the completeness property of the real numbers. Before we actually deep dive into completeness property, it is very important to know about what is meant by bounded above set, bounded below set, the upper bounds and the lower bounds, and supremum and infimum. And in the last part of this video, I will cover the completeness property. And I have made the chapters of this video as well. If you want to see the specific chapter, then go and check it now in this description box. So what is meant by the set is an bounded above. So the set is bounded above if, before that, let S is any non-empty subset of real numbers. Then this set is bounded above if U is any real number. If U is any real number and this U is greater than or equal to every element of S. If I found one U is any real number which is greater than or equal to every element of S for every element of X, then over S is bounded above. Means I have found a number, any real number, which is greater than or equal to every element of S. So this S is bounded above, and this U is called the upper bound of, it's called upper bound of S. For example, let's do an example. Let's say we have an open intervals 1 and 3. Let's say I have taken S is equal to n. As you know that it is a subset of real numbers. So S is here. We have 1 and we have 3, and between them, let's say we have 2. So this is an open interval. Now you can see that if I take any number here, let's say we have 5, and 5 is greater than or equal to every x belongs to this interval. Yes, S is greater than or equal to any, I think so greater than, not equal to, is greater than to every x belongs to this interval. So x, this 5 is an upper bound of this. If I found a upper bound of any set which is a subset of real numbers, then this set is called bounded above. If I found upper bound, then the set is bounded above. Now our next is what is meant by bounded below. Similarly, if I have S is any non-empty subset of real numbers, and I found last I will take U. Now we consider V, which is belongs to real number, and this V is less than equal to X for all X belongs to S. Means V is less than or equal to every element of a S. Then this S is called bounded below, and this U is called lower bound. Is called lower bound. For example, let's say, take this same example here. We have S is equal to 1 and 3, which is a subset of real numbers. You can see that. So now if this is this, 1, we have 1 here, 3 here, and between them, let's say 2. Then all the numbers here are always smaller than or equal to, or always smaller than these elements here. Exactly. Similarly here, all the numbers here are always greater than all the numbers there. Exactly. Similar to that, it is all the numbers here is greater than all the elements of this S. So if I take any number, here, for example, -1, let's say, or 0, then you can see that this -1 is less than all the element of X, which X belongs to over open interval 1 and 3. So this -1 is is our lower bound of open interval 0 and 1. Similarly, 0 is also an upper bound. So there are a lot of lower bounds. So if S is any subset of real number and you found any lower bound of it, lower bound may be more than 1 or infinite, maybe. So if you find at least one lower bound, then this set is called over bounded above. If you found any real number U which is greater than or equal to every element of S, then our set is bounded above, and the number U is over upper bound, and here our V is over lower bound. So what does mean by the set is bounded? If so, a set A set is bounded if it is both bounded above and bounded below. Bounded above and bounded. It means that this set has upper bound as well as lower bound. Meaning the upper bound and the lower bound of a set exists. So the set is called bounded set. Similarly, if set is unbounded, then it is not bounded. It is not bounded. So our next thing is very, very important. Okay, before that, we actually know that till now we know that this is our complete real number line. And we take a subset of it. Let's say this is our S. And this S is a subset of real numbers. Okay, till now we know that. Now all the numbers here and all the numbers there, all the numbers here are the upper bounds of S. We know that till now, okay? And all the numbers here are lower bound of S. Okay, so all the number on the right side of the S are greater than S, and all the number on the left side of S, will be lesser than all the elements of S, and all the number on the right side of S will be greater than the elements of S. I hope you all are super clear with this. Now, take a minute and think about that. If all the number on the right side of S are greater than S, then there exists a least number. Then out of these all number which are greater than S, there exists a very least greater number which is greater than all the elements of S. Similarly, here there is a least number here, least number which is greater than all the elements of S, and there is a greatest number. There's a greatest number which is less than all the elements of S. Okay, so all the numbers on the left side of S are less than S, and all the number on the right side of S are greater than S. So out of all these number which are greater than S, the least number which is greater than all the elements of S are called supremum. So least number greater than all the elements of S, greater than all elements of S, is called the supremum of S. Right? This supremum is oftentimes called least upper bound. And always remember that this supremum is always less than all the upper bounds because it is least upper bound. Okay, I hope it is clear to you. So the supremum is always less than all other upper bounds. Upper bound of set. Okay, so this is very, very important. So as I take the example here, which is an open interval 3 and 1 and 3. So here, which is an open interval, let's say 1 and 3 and 2, let's say here. So all the numbers here and here are upper bounds. So the least upper bound of this open interval will be here. So the least upper bound, so the supremum of, let's say, S is equal to this. So let's say S is equal to this. So the supremum of this S is equal to 3 because it is the least upper bound of S. So from here you can see that the supremum may or may not be belong to set. It is not necessary that supremum does not belong to set. The supremum may or may not belong to set. Supremum may or may not belong to set. Okay, so I hope this is very, very clear to you. Now, what is the infimum? As here, out of all the lower bounds, the greatest lower bound is called the infimum of a set. So, it is the greatest lower bound, the greatest number which is less than all elements of set. Okay? Okay. Or always remember that infimum is always greater than all the lower bounds of set. Similar to in Supremum, infimum may or may not belong to set. In the Supremum of set, may or may not belong to set. Or okay, so let's do an example. We have set S is equal to, let's say, 1 and 7. We have take now another example here. So a set, let's say 1 is here and 2, 3, 4, 5, 6, and here this is over 7. So here all the numbers here are the lower bounds of this set S. So the greatest of all the lower bound is this. So the infimum of S is equal to 1. And very, very important thing. Infimum of set is always unique. Similarly, it is always unique. Means in maths in maths, uniqueness means there exists only one. So the set, any subset of real number has only one supremum. Similarly, here I have no space. So let's do here. Infimum. Okay, 1 second. Okay, so we are here. So hashtag supremum of set is always unique. Any subset of real number has only one supremum and one infimum. So there exists not more than one. Only one supremum is allowed, and similarly only one infimum is allowed. Now, what is completeness property? If the completeness property of real numbers says every non-empty subset of S, so S is not empty set. S is not empty and S is a subset of real numbers, then if S is bounded above, then it has supremum. Then it has supremum in R. This is the first point of completeness property. And the second point is that supremum property, if S is non-empty and S is a subset of real numbers, if S is bounded below, then it has infimum in R. So this is the completeness property of real numbers. The completeness property of real numbers says that if S is any subset of a real number, then if S is bounded above, then its supremum exists. If S is bounded below, then its infimum exists. So this is the supremum property of real numbers, and the theorems about it we will cover in the next video. I hope this video is clear and this concept is clear. All of you, I hope you enjoyed the video. Please like, share, and comment our videos, and don't forget to subscribe our YouTube channel. Thank you so much.